Welcome back. For today's video, we're going to look at some energy problems. So we're going to work on some problems with gravitational potential energy, kinetic energy, and conservation of energy. So let's get started. For this first problem, we have some information that we're going to pull out. We have a 60 kilogram man. We have 20,000 joules of gravitational potential energy, and we're trying to figure out how high. So I'm going to write that stuff down. So we have a mass of 60 kilograms. We have a GPE of 20,000 joules. And we're trying to figure out the height. So if it's obvious what equation to use, write it down, get started. If it's not obvious, or if you need a little more help, or if you want to just make sure everything is good, we're going to draw a picture. So we have a man. He has a mass of 60 kilograms. The height is question mark. And he has a GPE, let's make those P's, of 20,000 joules. All right, so the equation I'm going to use is GPE equals mgh. So when I plug my numbers in, I get 20,000 equals 60. Gravity, we know, is 9.81, and h. So to solve this, I'm going to multiply 60 times 9.81, and I'll get 20,000 equals 588.6 h. And then I'm going to divide both sides by 588.6. And I'll get h is equal to, let me put it in the calculator, I get 33.98 meters. And that's my answer for gravitational potential energy. All right, the next one, I'm going to do the same thing. We have a 6 kilogram bowling ball. We have 4,000 joules of kinetic energy, and we're trying to figure out how fast. So I have a mass. I have kinetic energy of 400 joules. I'm trying to find V. If I want to draw my picture, let's draw that in a straight line. Okay, we have our ball. It has a mass of 6 kilograms. It's moving at some unknown velocity, and we know the kinetic energy is 400 joules. All right, so the equation that I'm going to use is KE equals 1/2 mv squared. So I would have 400 equals 1/2 times 6 times v squared. So the first thing I'm going to do, I'm going to take half of 6. Half of 6 is 3. I'm going to divide both sides by 3. So 400 divided by 3 gives me, I'm going to put it up here, I get 133.33 equals v squared. And then I'm going to take the square root of both sides to get v. So the square root of 133.33 is 11.55 meters per second. And that is my answer. All right, let's move on to conservation of momentum. So we have some information. Moops has a mass of 16 kilograms, standing on a diving board that is 12 meters high. We're trying to figure out how fast he's falling. So let's write down some information. We have a mass, we have a height, and we're trying to figure out V. So if you look carefully, there is not an equation that has m, h, and v in it. So we have to make our own. So The other way to think about it is if you're confused and you don't see an equation, draw a picture. All right. So let's redraw this. Let me redraw it the right way. We got a diving board, and then we have water at the bottom. And at the bottom, when he's down here, V is question mark, and we know this height is 12 meters. Okay, so what I'm going to do is I'm going to define 2 points. I'm going to call this point 1, and I'm going to call down here by the water point 2. And I am going to say the total energy at point 1 has to equal the total energy at point 2. That's conservation of momentum. Energy is not created or destroyed. It's equal between any 2 points. It's equal before and after he jumps. So now I have to define what is the total energy at the top, at point 1. And I would say because he has a height, he has a GPE. And at the bottom, he's moving. So he has kinetic energy. So I can rewrite this as this. And now I'm going to plug my numbers in. So I would have 16 times gravity times my height equals 1/2 of my mass, which is 16, v squared. So I could multiply this all out, but I see that there's a 16 in all terms. Every term, the term on the left side and the term on the right side have a 16. So I can divide the 16 out and I can cancel that. All right, so now on the left side, I'm gonna multiply gravity times the height, and I would get 117.72 equals 1/2 v squared. To get rid of the half, I'm going to multiply by 2 to both sides. And I would get 235.44 equals v squared. And now I'm going to take the square root to get v by itself. And when I take the square root of the answer, I get 15.34 meters per second. Excellent. So these conservation momentum problems, we're comparing the energy between 2 points, like right there, but they can look different. So let's look at another problem. All right, for this one, we have a mass of 4 kilograms. We have 20 meters per second. That is a velocity. And we're trying to figure out how high. All right, so let's draw our picture. Here's the ground. We're launching it at 20 meters per second. It has a mass of 4 kilograms, and it's going to go to this height, and we don't know how high. So I'm going to do the same thing. I'm going to compare the energy between 2 points. I'm going to make my own equation because I don't see an equation that I can use, and I see that I'm comparing this point and this point. It doesn't matter which one I call 1 and which one I call 2. I'm going to call this one 1 and this one 2 just because we're starting at the bottom. So I'm going to call 1 at the bottom because that's where we start. At the bottom, it only has kinetic energy. There is no height, but it's moving. At the top, it has gravitational potential energy because it has a height, but it's not moving at the top. Remember, when something goes up, it continues to go up until it reaches the top, and then it pauses, it stops before it comes back down again. So I can rewrite this as that. And then let's plug our numbers in. Oh, so the reason I'm doing this, at the bottom, it has kinetic energy, and at the top, it has potential. So I would have 1/2 for v squared equals mass times gravity times height. All right, same trick as last time. I could multiply this all out, but I see a 4. So I'm going to cancel those 4s. So I have half of 220 squared. 20 squared is 400. Half of 400 is 200. And then to find h, I'm going to divide both sides by 9.81. So we have 200 divided by 9.81. We get a height of 20.39 meters. All right. So this was a similar problem to the last one in that we used conservation of energy, which is that equation, but it looked a little different. Let's do another one that looks different still. All right, a roller coaster is at rest at the top of a 20-meter high hill. It rolls back down to a 12-meter high hill. How fast is it moving? Okay, so if something is at rest, I know it starts at 0. I have a height of 20 meters, and I have a height of 12 meters, and I'm trying to find a V. So I have 2 V's and 2 H's. That's kind of weird. So once again, if I don't understand what the problem is saying, I draw a picture. So we have 2 hills. So I'm going to draw them and label them. Okay. It's at rest up here, but then here it's moving. We don't know how fast it's moving. So once again, sometimes just pulling out the information does not give me enough visual to understand what's happening. So drawing the picture gives me those visuals sometimes. All right, so once again, I don't see an equation, but I do see that I'm starting at this point and I'm ending at this point, so I can compare those 2 points, point 1 and point 2. So I'm going to use this equation again. I'm comparing the energy between 2 points. All right, hill number 1, I have a height, so I have a potential energy, but it is not moving. It started at rest, so there's no kinetic energy. On hill 2, it also has a height, so it has potential energy, but it's moving too, so it has kinetic. So our energy looks a little different, our equation looks a little different. So we would have mgh, this is from hill 1, and then we have mgh plus 1/2 mv squared, and this is from hill number 2. All right, let's plug in some numbers. So I have, I don't have the mass. If I don't have the mass, I'm going to call it m. I don't know what it is. Could be any number. Then we have 9.81, and we have the height. Okay, it equals, now I'm at point 2. Point 2, I also don't know the mass. So I'm going to call it m. 9.81, 12, plus 1/2 m v squared. All right, I don't know the mass. I didn't freak out and just stop. I don't know the mass. I just keep the pencil going and I write it out and I put the m in there. Sometimes you'll see what's happening. And what I see is there's an m in every single term. So because there's an m, let me rewrite that. Because there's an m in every single term, I can cancel those m's. I cannot cancel the 9.81 because the 9.81 is not in every term. It's not in that last term, but it is in the first 2. So I can't cancel it. I got to leave it there. All right, so let's math it out. We have 9.81 times 20 is 196.2. And then I have 9.81 times 12 is 117.72. And then I still have 1/2 v squared. Awesome. I'm going to combine like terms. So I'm going to subtract this from both sides. So I have 196.2 minus 117.72. And I get 78.48 equals 1/2 v squared. So I simplified it a little. I'm going to keep trying to isolate that v. So I'm going to multiply both sides times 2. That will get rid of the half. So I'll get a v squared on this side. And I get 2 times 78.48, which is 156.96. And then the final step would be to take the square root, and I get b equals 12.53 meters per second. All right. So technically, when you take the square root of a number, you do get a positive or negative. And for this one, it's moving right. And so we would call it positive. But if you were looking from the other direction, it would look like it's going to the left. Like if you were facing the roller coaster from the opposite side, it would look like it'd be going to the left. So for this one, positive or negative would be the correct answer. For this one, it's going up, so the height should be positive. Let's just double check these. For this one, we had the same thing. We took a square root. It should really be positive or negative. And really, we should have the negative 15.34 because it's going down. So technically, that would be the right answer. Because it's going down, not up. So our velocity needs the direction. And then for this one, same thing. We get positive or negative because we took the square root. This one's going right. But if you were looking at it from the other direction, it'd be going left. So either one should be accepted. I would just put it as positive because in our picture, it's going right. And this one is a height. So it makes sense that we get a positive answer. And there's no square root. Really, we just run into those problems with the square roots. All right, last question. Let's pull out some information. We have a 100-kilogram car, 10-meter high hill, at rest. We have a velocity of 14 meters per second, and we're trying to figure out energy lost. Okay, so let's write down what we know. We got a 100-kilogram car. We have a height of 10 meters. We have at rest, and then we have a velocity of 14 meters, and we're trying to figure out energy lost. All right, so let's draw our picture. Okay, so up here, we have a 100-kilogram car, height of 10 meters, and it's at rest. Down here, it's moving. At 14 meters per second, it's still a 100-kilogram car. And we're trying to find the energy lost. So I'm going to use conservation of momentum again. I'm going to call this number 1. I'm going to call down here point number 2. And I'm going to say the energy at point 1 has to equal the energy at point 2. At point 1, it has stored gravitational potential energy. At point 2, it has kinetic energy, but in this problem, it's saying energy is lost. So we also have energy lost at point 2. So all of this stored energy here at the top, as the car goes down, that stored energy turns into kinetic energy, and we lose the energy. So we're losing energy between points 1 and point 2. So that's why I have to include it right there. All right, that's the energy lost between the 2 points. So I would have mgh equals 1/2 mv squared plus energy lost. All right, let's plug some numbers in. We would have 100 times gravity times height equals 1/2 mass v squared plus energy lost. So I do see 100. It's in 2 terms, but I don't know if the 100 is in the energy lost. I don't know if that mass is in the energy lost. Most likely not. So I can't cancel 100 because the 100 is not in every term. But I can multiply these out. The first one, I would have 9.81 times 10 times 100 is 9810. And on this side, I have 14 squared times 100 times a half, and I have 9,800 plus E lost. Okay, I'm going to solve for energy lost. And I have energy lost is 10 joules. All right, so we had 10 joules lost. That was lost to heat and drag is what it said up here. Friction and air resistance are causing energy loss. All right, hopefully you understood these. Hopefully this helped. If not, please come in, ask me for assistance, and I would be more than happy to help you out. Have a great day. See you next time.